Okay, in this video, I'm just going to go over question 9 from the U1A7 homework. This is some trickier problems with equation laws when we've got multiple variables or multiple letters in our question. So the first thing I'll say is that these type of questions are more common in grade 10 or 11 math. So we won't probably have questions of this difficulty on the test, but I know many of you are interested. So I think I'll go over them now because we can solve them with the rules that we've learned so far. So let's take a look at 9a first. Now, because I'm multiplying, I don't actually need to include the multiplication symbol, so I can rewrite it like that. We know if I have no exponent, I can just write in a 1. Then I could also just rearrange. Multiplication is commutative, so the order I multiply things in doesn't matter. So if I group the a's together, and I group the b's together, that's not changing my product. And then now I can use the exponent law. So if I'm multiplying exponents with the same base, I can add. So 4 plus 1 is 5, and 5 plus 3 is 8. So that's one way we can think about multiplying exponents when I have bases that are different variables. You could also, if you prefer, as we practice these more, just kind of look at this and do this in one step. I'm going to multiply my a's together first. 4 plus 1 is 5, and then when I multiply my b's, 5 plus 3 is 8. So whatever works for you, if you want to work through the steps on your paper, or you want to do it in one step, that works as well. I know that's not a great 5 with my pen. Let's take a look at b. I'll just show you one other way to do it. If I wanted to write this out in long form, I would have m times m, and then I have 4 n's multiplied together. And then I've got multiplied by 3 more m's and 3 more n's. So I'm multiplying all of these variables together. Here they are in long form. So, well, how many m's do I have in total? Well, I've multiplied 2, and then I've multiplied 3 more. So I have m to the 5. How many n's do I have? Well, I've got 4 n's, and then I'm multiplying by another 3 n's. So I'm multiplying a grand total of 7 n's together. So if you want to think about it in long form, if that helps, that's fine as well. Again, I could do this in one step just by multiplying the m's together. Same base, so I can add the exponents. 2 plus 3 is 5, and 4 plus 3 is 7. Division works the same way. I'll show you one example in long form. I think it's easier when we're talking about division to always think about division as just a fraction. I'm dividing the numerator by the denominator. So I've got 6 p's and 5 q's on top. On the bottom, I've got 3 p's and 2 q's. So p divided by p is 1, so that cancels out. P divided by p is 1. P divided by p is 1. So I'm left with 3 p's on the top. Q and q. Q divided by q is 1. Anything divided by itself is 1. I'm also left with 3 q's on the top. So my final answer would be p times p, which is p to the power of 3, multiplied by q times 2, q, which is q to the power of 3. Again, I could also just use my exponent rules. I could divide my p's first. If I'm dividing powers with the same base, I subtract the opponent. 6 minus 3 is 3. 5 minus 2 is also 3. So if you want to think about it in long form, if that helps, that's fine. My one recommendation is to always think about division as a kind of a fraction problem. Let's take a look at d. Again, I'm going to set this up as a fraction. And we're going to do the coefficients first, then the x's, then the y's. 6 divided by 2 is 3. So we're just using our normal division of numbers for coefficients. X, and there's nothing on the bottom, so x divided by 1 is still x. And then this is really a y to the 1. Y squared divided by y. Well, same power, same base, so I just subtract the exponent, so I'm left with y to the 1 or just y. So normally it's not wrong, but normally we wouldn't communicate our math. We don't normally write the exponents in our final answer. So if you do, I wouldn't mark it wrong, but it's a good communication habit just to write them without the exponent if the exponent is 1. Let's keep going. E is power to a power. So I have gh to the power of 4 cubed. Again, what I'm really doing is I'm taking g to the power. So if it helps, you can kind of think about distributing the exponent of 3 to everything inside of the brackets. So what I'm really left with here is g to the power of 3 multiplied by h to the power of 4 cubed. And we know that when we do power to the power, I'm just multiplying my exponents, so I'm left with h to the power of 12. So everything in the brackets, whether it's a variable or a coefficient, which is just a number, I'm applying the exponent to. So everything in the brackets is part of my base. Let's take a look at f. Now we're going to start some more interesting kind of multi-step problems. So I have 2k squared m cubed multiplied by 2k squared squared. So as my first step, I'm going to do my brackets first. So again, I'm applying, because the 2 is inside the bracket, it's part of the base, so I need to do 2 squared, which is 4. And then k squared to the power of 2 will be k to the power of 4. Now I'm multiplying everything together, so let's do the coefficients first. 2 times 4 is 8. K squared times k to the 4, I just add the exponents, is k to the 6, and then I've got m cubed. So just remember, people sometimes get a little bit caught up. When I'm multiplying or dividing coefficients, I'm just using my normal multiplication and division of integers. I'm not worrying about the exponent rules. We've got a couple more to try, so I'll try to fit them on the bottom of this page. And again, I like to think of any division problem as a fraction. So you notice there is a difference when I have the base in brackets. What this means is that this exponent 2 on the top is getting applied to everything. It's getting applied to the coefficient 2. It's getting applied to g to the power of 5. And it's getting applied to h to the power of 3. But on the bottom, we don't have the brackets. So this 6 exponent is only being applied to what's directly next to it, only applied to the h. So let's simplify the top. 2 squared again is 4. G to the 5 to the power of 2, well, it's power to a power, so I multiply the exponents for g and h. And there's nothing to do yet on the bottom. And now 4 divided by 2 will be 2. G to the power of 10 divided by g will be g to the power of 9. I just subtract my exponents. And then h to the power of 6 divided by h to the power of 6 just cancels out. That's just equal to 1. So my final answer would be 2 times g to the power of 9. Let's look at h. I'm just going to flip my page over so I can take up kind of our last and our longest problem. Let me kind of rearrange my paper. So this one's already written for us as a fraction. So I'll do the top. I'll do coefficient times coefficient. So 6 times 3 is 18. B squared times b squared, same base, so I add the exponents. And then d to the 1 times d squared would be d cubed. And on the bottom, I'm distributing my exponent 2 to the 3, to the b, and to the d. So 3 squared is 9, and then I've got b squared, d squared. And now I can divide. 18 divided by 9 is 2. And now I'm just using my exponent rules. So if I'm dividing with the same base, I'm just subtracting the exponents. So my final answer is 2b squared d to the 1, but I'm not going to write the 1. So hopefully that helped. If you have any more questions, please comment on the YouTube video or send me an email. Again, these are questions that you're more likely to see as you move on into grade 10 or 11 math, but I know that you're all more than capable of trying and excelling at these questions now. Okay, thanks and bye for now.